One thing that is mentioned often when the topic of AI is discussed is, can we trust it and what it says or does? Will AI become a primary source of misinformation and be singularly untrustworthy? These are all good and reasonable questions to ask. So what is the definition of untrustworthiness when it comes to AI? Any algorithmic system, for example machine learning model, rule-based engine or generative model that produces outputs that are false, biased, opaque or otherwise unsuitable for the intended purposes, and for which users cannot reliably assess reliability. AI is much in the news with new developments happening every week. So this rapid change is making some people uncomfortable, as they struggle to comprehend just where all this is going. But trust, or the lack of it, is nothing new.
The Genin article, folks. Accept no substitutes. This miraculous snake oil is guaranteed to cure what ails you, or your money back.
We humans have been dealing with trust issues for millennia, albeit with other humans rather than AI systems. How many untrustworthy individuals have you met in your lifetime? So what is the definition of untrustworthiness when it comes to human interaction? An individual or group whose statements, decisions or actions are deliberately or unintentionally misleading, biased or inaccurate. So the need to deal with inaccurate information is nothing new, where any data, claim, recommendation or decision that diverges from the objective truth, domain-specific standards or user expectations, potentially causing harm or misallocation of resources. As societies, we have developed our own protocols to deal with human trust, or the lack of it. Sometimes this works, and sometimes it does not. So let's have a look at the core drivers of inaccuracy in both humans and AI systems. Cognitive design bias. In humans, we have confirmation bias, motivated reasoning, or cultural stereotypes. In AI, we have training data bias, algorithmic bias, or model architectural choices. Both of these embed pre-existing prejudices into outputs. Knowledge gaps. In humans, we can have a lack of expertise, misinformation, or memory errors. In AI, insufficient, noisy, or outdated training data, or limited domain coverage. In both of these, missing or faulty knowledge bases lead to erroneous conclusions. Intentional manipulation. In humans, we can have deception for personal gain, propaganda, or cover-ups. In AI, we can have data poisoning, adversarial attacks, model hacking, or strategic omission of safety constraints. Deliberate sabotage can be injected by actors on either side in both human and AI systems. Resource constraints. In humans, we can have time pressure, fatigue, or even limited access to facts. In AI, we can have compute limits, latency constraints, model size trade-offs, or budget-driven simplifications. In both, constraints force shortcuts that degrade the fidelity of the outcome. Feedback loop failures. In humans, ignoring corrective feedback or echo chamber reinforcement. In AI, a lack of human-in-the-loop monitoring, or reinforcement learning on biased reward signals. In both of these, the absence of corrective signals allows errors to self-reinforce and propagate. So how can these problems manifest themselves? Factually wrong statements. In humans, a news anchor cites a misquoted statistic. In AI, a large language model hallucinates a non-existent study. In both, the output appears confident despite being false. Selective omission. In humans, a spokesperson omits adverse trial results. In AI, a recommendation engine ignores negative reviews because they were underrepresented in the training data it was provided. In both, critical information is missing, which will skew the decisions made. Overgeneralization. In humans, a manager applies a single anecdote to all employees. In AI, a vision model misclassifies novel objects based on similarity to training set data. In both, general rules are applied beyond their valid scope. Misattribution. In humans, a scientist attributes another's work to themselves. In AI, an AI tags a copyrighted image as public domain. Attribution errors affect credibility and rights. Confidence inflation. In humans, a doctor expresses certainty despite ambiguous tests. In AI, a deep learning classifier outputs a high probability for a low confidence prediction. Trust problems will, of course, have consequences. Safety. In humans, wrong medical advice can lead to patient injury. In AI, autonomous vehicle misrecognition can lead to collisions. Loss of life or injury due to erroneous decisions is a major problem. Economic. In humans, fraudulent financial advice can lead to monetary loss. In AI, algorithmic trading errors can lead to market volatility. Direct financial damage and erosion of market confidence can be the outcome in these cases. Social. In humans, we have hate speech, misinformation leading to polarization of views. In AI, deepfake generation, biased moderation can lead to artificial echo chambers. In both, societal trust erosion and amplified misinformation cycles are the outcome. Legal and regulatory. In humans, we have perjury, false statements leading to litigation. In AI, non-compliance with GDPR or the EU AI's Act's right to explanation can lead to large fines. Liability disputes and regulatory sanctions can be the outcome. Reputational. In humans, damage personal or brand credibility. In AI, brand backlash from biased AI outcomes. Both of these lead to long-term loss of stakeholder trust. So what are the strategies we can use to mitigate the risks of loss of trust in both humans and AI systems? Transparency. For humans, we need clear sourcing, citations, and disclosure of conflicts of interest. For AI, we need model documentation, model cards, datasheets, and explainability techniques. These will lead to stakeholders being able to evaluate provenance and reasoning. Verification. In humans, fact-checking, peer review, and audit trails are essential. In AI, automated validation pipelines, cross-model consistency checks, and keeping humans in the loop to review outcomes. In both, independent verification before information gets disseminated. Bias audits. In humans, diversity training, or bias impact assessments. In AI, we need fairness metrics, bias mitigation algorithms, and dataset audits. With methodical dedication and rectification of consistent errors, problems become less. Accountability. In humans, legal liability, professional standards, and whistleblower protections. With AI, we need traceable logs, model versioning, and responsibility clauses in contracts. For both, we need clear attribution of responsibility for any errors that occur. Feedback loops. In humans, open channels for correction. For example, documentation of errata and retractions where necessary. In AI, continuous monitoring, online learning with corrective signals, and post-deployment testing. For both, adaptive improvement based on real-world performance. Robustness. In humans, we need redundancy. That is, multiple expert opinions. In AI, adversarial training, uncertainty measurement, and fallback systems based on rules. For both, resilience against intentional manipulation and random noise is essential. So what are the takeaways from looking at this comparison between human and AI systems? Confidence versus the accuracy gap. Both humans and AI often exude confidence that outpaces factual correctness. Users must be trained to interpret confidence cues critically. Bias propagation. Pre-existing prejudices are amplified when humans and AI interact. For example, biased human labeling reinforces AI bias. Intentional versus unintentional harm. Distinguishing malicious manipulation from inadvertent error is essential for appropriate response and remediation. Regulatory alignment. Emerging AI governance, for example the EU AI Act, mirrors existing professional regulations, for example medical licensing, suggesting that compliance frameworks can be co-designed. Human-AI symbiosis. The most effective defense against misinformation leverages the complementary strengths of both: human judgment for contextual nuance, AI for scale and pattern detection. So, in summary, untrustworthy humans and untrustworthy AI systems share a common failure mode, delivering inaccurate information that appears credible, thereby misleading downstream decision makers. The root causes: bias, knowledge gaps, intentional manipulation, resource constraints, and broken feedback are analogous across both the biological and computational domains. By recognizing these parallels, organizations can adopt integrated governance that applies transparency, verification, bias mitigation, accountability, and robust feedback to both human actors and AI tools, ultimately safeguarding trust, safety, and societal well-being. But that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.